Next unit in unit 2 is about sensors. So in this session we will see temperature and humidity sensor, and next is PIR sensor. So first, temperature and humidity sensor, it is called as DHT22. So temperature sensor will measure the warmth and coldness of any object or any substance. Next, humidity sensor means it will measure the water vapor in the atmosphere. So DHT22 means it is digital humidity temperature sensor. It will sense humidity and temperature and give the output in a digital format. So DHT uses capacitive humidity sensor and a thermistor to measure the surrounded air, and whatever the output it is getting, it will give it in the digital signal to the data pin, that is output pin. So next, the different features of this temperature sensor is, these are the default features. Ranging operating voltage is from 3 volts to 5 volts. It measures temperature range from minus 40 degrees to plus 125 degrees centigrade. Measuring range of humidity is from 0 degrees to 100% with the accuracy of 2 to 5%, and maximum operating system current of DHT sensor is 2.5 milliamps. These are the some of the features of temperature and humidity sensor. Next, description of the temperature sensor. So this temperature sensor will consist of 4 pins. So first pin VCC. VCC represents the power pin and data output. This pin will give us the output in a digital format. Next is NC. NC is a not connected pin, and next pin is a ground pin. So this is the pin description of the temperature sensor. Next we will see how the temperature sensor will work. What is the working principle of the temperature sensor? So the DHT sensor will consist of 2 electrodes. In between the 2 electrodes you will be having a substrate. So this substrate will hold the moisture or humidity. So if the humidity or moisture changes, then the conductivity of the substance also changes. That means, or you can say, resistance of both 2 electrodes will also change. So the change in the resistance is measured and processed by an IC, which is 8-bit microcontroller, and it also consists of a thermistor, which is a variable resistor. So that changes in resistance with respect to the temperature. It is made up of ceramic and polyceramic substances. So these substances will help or provide us large changes in the resistance by only just small changes in the temperature. In order to provide this, we are using the materials called as ceramic or polyceramic. And the applications of temperature sensors are, you can use it in fuel management, chemical management, or weather stations. Next type of sensor is PIR sensor. PIR stands for passive infrared sensor. So this passive infrared sensor is an electronic sensor. It will measure the infrared light radiating from the object in its view or in its sensing range. And next, PIR sensor can detect what is the movement of the object in front of it. So this will explain in detail in the next slides. The term passive here means it will refer to the PIR devices. That means it will not radiate energy, but it will detect the radiating energy from the objects which are moving in front of that sensors. So next, the pin description of PIR sensor. PIR sensor will look like this. It will be having 3 pins. First pin is the power supply pin. Second pin is a output pin. Third pin is a ground pin. So these are the 3 pins for PIR sensor. If you see in detail the PIR sensor, it will consist of these pins are the 3 pins that it is been represented in this diagram. Other than this, the more that you have to know about PIR sensor is, you are having 2 potentiometers. One potentiometer will represent delay time, another potentiometer will represent sensitive time, and this is the jumper. Under this jumper you will be having 3 pins. You can make jumper low, you can make jumper as high. If you keep jumper on first 2 pins, it represents the jumper is low. If you keep this jumper on second and third pin, it represents the jumper is high. This is a PIR sensor, passive infrared sensor. This consists of a dome like structure, honeybee structure. Inside this, if you see, this is the sensor that will detect the infrared light radiations emitting from the object in its particular range, in this sensor range. Next, the pin diagram, it consists of 3 pins. If you see here, VCC is the power supply, and this is the output pin, and this is the ground pin. And the more important one that you should know in PIR sensor are these 2 potentiometers. One potentiometer is for delay, another potentiometer is for sensitivity. And next, this is the jumper pin. You will be having 3 pins inside this jumper, like this 3 pins. First 2 pins, if you keep jumper on first 2 pins, that means you are making the jumper as low. If you are placing the jumper on second and third pin, then that means you are making the jumper as high. So here this is the high representation. If you are making first 2, this is the low, jumper is making as low. So this is the PIR sensor, and the detailed explanation is there in the PPT. So here actually how it works is there in this slide. So whatever I told in the previous slide, same thing here. There are 2 potentiometers. 1 meter represents delay time and 1 meter represents the sensitivity. What is delay? Means for how much time you want the output to be seen. So basically it can handle from 0.3 seconds to 5 minutes. Whenever the object is passing through the range of this PIR sensor, for how much time you want the output to be seen is called as delay sensor. So this you can fix here. With the screw you can fix the delay time for how much time, from 0.3 seconds to 5 minutes. Next is sensitivity. Sensitivity means the distance of the object, the range of the object from which you can measure. So the basically it can measure up to 7 meters. So this is the sensitivity potentiometer. With the screw you can adjust it till 7 meters. So the distance to which you can see the object. And next I told there is a jumper which you can make it as low or high. Low you can make jumper if you keep first 2 pins. That means what is the meaning of making the jumper as low is you are getting the output only once. That means suppose some object is passing through and you are getting an output as 3 volts. So suppose you are setting the time as 2 seconds. After 2 seconds you will be getting output as a square wave 3 volts, and after that the sensor will be deactivated. That means the output can be visible for only one time. That is the meaning jumper is low. If jumper is set to high means continuously if you want the output to the particular time whatever you have set. That means for every 2 seconds if one object is coming you will be getting output as 3 volts. If some other object is coming again you are getting it as 3 volts. So continuously if you want to get the output you can make the jumper as high. That is the meaning as repeatable trigger, non-repeatable trigger. This will work depending upon how you are setting the jumper, whether to low or high. So this is the main description and working principle of PIR sensor. If you see this diagram, this is the PIR sensor where you are having different lenses. These lenses will detect the infrared light radiations from the object. Now in the range of this PIR sensor, so the range of PIR sensors, some sensors will have 180 degrees, some sensors will have 360 degrees. So within this range if there is any object can be a thing or it can be an animal or it can be human being, any object can be there. If it is passing through the range then it will detect and then some output will be generated in form of a graph. Same example if you take it in a room, in a home automation, if you want to do with this sensor, whenever the person is entering the room you want to on the lights of that particular room, then you can use this type of sensors. So when an object such as person passing in front of the wall, the temperature at that point's field view will rise from temperature to the body temperature, and from the body temperature it will again return back. So the sensor will convert the resulting change in incoming infrared radiations into change into the output voltage and triggers is detected. Trigger is detected in a form of a waves or a graph, temperature graph. So the applications where you can use this PIR sensor is home automation, in security alarms or lifts. So basically the functionality of PIR sensor is, whenever you are keeping a PIR sensor in particular room or particular area, if there is any object passing in that field, it will detect that object. So it can only detect the object, but it will not tell what is that object or who is that person. It can only detect the object. That is the use of PIR sensor. Thank you.